Good afternoon, everyone. Welcome you to this webinar hosted by Lieber and accompanied by TwinTech and Fraunhofer. My name is Philipp Kalender. I'm head of consultant at Lieber and I have the honor to host and moderate this webinar, which is all about model-based engineering of digital twins and also the combination of asset administration shell generation and how to integrate this with an MBSE toolchain. Basically, what we want to show you is how to combine these two worlds, so having the engineering models combined with the digital twin models. For us as tool vendor in the MBSE world, this is especially important because we also are involved in a research project called Matisse, which is model-based engineering of digital twins for early verification and validation of industrial systems. And here you can see how this can be achieved. So how digital twin engineering and MBSE can be aligned, because on paper it might feel that these are two completely different worlds, but we don't think this is like that. So we want to show you how this can be possible using a specialized enterprise architect plugin. And for showing you this in detail, I'm today joined by Daniel Lehner from TwinTech and Philippe Barbie from Fraunhofer Institute. They will do most of the presenting. They will dive into the topics and demonstrate the toolchain. I'm here for moderation and handling the Q&A. So if you have any questions, please feel free to type them into the Q&A tab here in Zoom. All the questions will be collected there. And at the end, so roughly 15 minutes at the end, we will take some time, go through the questions and try to address them. Don't be shy and put all the questions in there. If there are too many, we will gather them, answer them, and then send answers out at the end. So afterwards, there will also be a recording of this webinar available. So if you have any questions, please put them into the Q&A section. And also a small announcement. So the topics covered here, so MBSE, digital twin, asset administration shell, will be covered in some workshops in somewhere in April. We will announce that afterwards. And if you're one of the lucky attendants here in this webinar, you can also register for this webinars and these workshops with a discount code. This will be sent out later on and we will give you more information on that. But just as some appetizer, I can already announce this. More details on this later. And basically, I want to now give over the microphone to Daniel for the first introduction and enjoy the webinar.
Thank you very much, Philip. Thank you for the virtual microphone. I will use that and start sharing my screen. While I do that, let me already start introducing myself. I'm Daniel Lehner. As Austrians used to say, my position is, well, I'm founder and CEO of TwinTech. What we do at TwinTech is training and consulting on AI and digital twins for manufacturing. So we see ourselves as boutique consultancies. So we try to really find and get access to the experts on AI, on digital twins, and then provide our customers with access to these experts via, again, training and consulting. So tailored trainings and consulting. But enough for me on FMIs on TwinTech. As Philip already said, today's topic is about bridging two worlds. On the one side, systems engineering, MBSE, enterprise architect as representative MBSE tools. And on the other side, digital twins, asset administration shell as a representative standardized model for that. And what we do is, in the end, two things. First of all, what Philippe from Fraunhofer will show you is how can we reuse existing enterprise architect models to generate digital twins. Why would you do that? Because we gain the whole power of this digital twin world. So we can get access to operational data, so telemetry data, for example, semantic data about stuff we have modeled in the enterprise architect. And what the asset administration shell also provides us standardized data structures that we can use in a drag and drop manner in the enterprise architecture to gain speed during development. And the second point that I will try to make later is if we already have digital twins, or if you want to develop digital twins, is a lot of tooling surrounding the asset administration shell. But today we want to show the benefits of modeling these digital twins in the enterprise architect, because this allows us to leverage this whole systems engineering power. So digital twins is a very niche topic, let's say, and there are a lot of tools there. We've written papers on this, but in the end, or white papers on this, but in the end, system MBSE is there for much, much more time, and especially the enterprise architect has so much power that we want to reuse, or that we want to use to build our digital twins. And we also have additional tools like, for example, the LemonTree for configuration management that we can also leverage, or that we get for free in the sense as of out of the box if we use an MBSE toolchain. And with that being said, with this first primer, I want to hand over to Philippe, who will start with the first point of today.
Yeah, hello everyone. So I'm the second Philipp here, Philipp Barbie from Fraunhofer IESE. I am a researcher there at Fraunhofer Research Institute IESE. And today I want to talk with you about the automated generation of standardized digital twins. I will share my screen here. And okay, let's dive directly into the topic. First of all, a little introduction about what are digital twins. So digital twins represent a real asset, a real system in digital space as digital representation. So we have to represent all properties that are relevant to specific use cases inside that digital twin. That does not mean that we have to represent all aspects of a physical system in that digital representation, but those that are relevant to those specific use cases we need to use or we want to use. So another important aspect about digital twins is that the communication between the digital twin and the real world asset must work in both directions. You see that on the right side in the picture, that we can see the current status of a real system in our digital representation. But we can also put data into our digital representation to influence the behavior of our real system. Another important part is standardization. So we want that this digital representation is stored in a standardized and structured form, so that we enable interoperability with other systems, and maybe even other systems from other companies that also use the same standard. So how to do that? We use something that is called the asset administration shell. The asset administration shell is a standardized implementation of this digital twin concept. It is standardized in the IEC standard 63278. And as you can see on the right side, you see there this satellite and the AAS. The AAS is the digital twin for that satellite, and it contains different submodels that cover different use cases of our satellite. So, for example, this could be real-time data, like real sensor data. In the second you want to see what is the temperature in the satellite or something. It can be simulation data that then can be used to simulate certain use cases. And we could have static data like a manual, for example. And those submodels, those can be either be custom created submodels, but there are also standardized submodels that are standardized by the EDTA, the Industrial Digital Twin Alliance. So you get those online for free, and for a lot of use cases, there is also it's already done a lot of standardization to use that submodels in your assets. So now, what we talked about is the concept and idea of a digital twin. So we have a digital representation of our real world system. And we have talked about the asset administration shell as a standardized way to do that. So what we're still missing is the technical implementation of that. And we are using, for that case, the open source middleware basics. That is a technical implementation of the asset administration shell standard. So, but now back to topic. Whoops. Back to topic. So what is our motivation for the automatic generation of digital twins? So you can see here on the bottom, on the left side, we have our physical system. On the right side, we have our digital twin, our asset administration shell. And the question is, how can we get from left to right? And of course, you could do the manual work of designing the digital twin, the asset administration shell by scratch, from scratch. But what you also could do is you could reuse a MBSE system model that you maybe already have of that physical system. So maybe you already have the system model for that system. Maybe you want to create a new asset administration shell. But in both cases, you can use MBSE techniques to make your lives a lot easier. Because MBSE techniques, as you maybe already know, give you a lot of tools and methods for documentation, for structured modeling of a system. And yeah, in this case, it's just another use case. You can take off your MBSE models to generate instances of digital twins for your implemented systems. So in the end, to rephrase that, you have two use cases you can fulfill with that approach. The first one is you can transform an already existing system model into an asset administration shell. And the second one would be to initially design an asset administration shell, or maybe a submodel that you want to be standardized in the future. You can design that in Enterprise Architect as an MBSE model to then have a single source of truth for generating both the documentation as well as the digital twin itself. And I will show you both use cases in a small demo. And I would say let's dive right into Enterprise Architect and basics so I can show you how you do that. So first of all, I will show you here the browser. Here's running basics in the background. So at the moment, it's empty. There's no asset administration shell, but we want to change that. So let's go right into the Enterprise Architect model. First of all, I will show you the example use case for that space satellite. This is also our example here. So you can see a system model of a space satellite. Of course, please, this is not a real satellite. This is just a explanation case. So it's really simple, but you will get the idea that this can already show how you transport the MBSE model into the digital twin. So, but of course, this is not a real satellite. So what you can see here, we have different blocks inside that satellite decomposition. One is environmental observation, one is energy management, and one is the mobility block. And inside these blocks, we define different sensors and actuators. For example, here is the temperature sensor. You can see it has different properties like manufacturer and temperature. If you want, you can look at the right side here on the features. You see more information about these properties, about this temperature sensor, for example. So the manufacturer, this is stored as a string, and we can give it an initial value that will be transported to the asset administration shell when we generate it with our tool. So we also have the temperature. This, of course, is a float. And it's also here already documented in which unit it is measured. This is really, really important. If you have digital twins, always you have to document in which unit you are measuring things for interoperability. So, and of course you can give initial value. This will be then changed in real time as soon as you connect your real world sensor to it. So this is our system model. And let's say we want now to build a satellite and then build a digital twin for it. So what we need to do is we need to add a few things, but it's not much. We need to add entry points for our submodels that define where in the system decomposition it will start to analyze your system and then generate this submodel. So for example, I did here 3 submodels oriented on this 3 blocks: environmental observation, energy management, and mobility block. So then what we need then is an asset administration shell block here, an element that defines what submodels should be part of my asset administration shell. So I define that here. And once I defined that and connected it to my model, I can select my asset administration shell. And then I can use this add-in to generate the digital twin, the asset administration shell. I click here on create new AAS instance. And then let's say we build a new satellite. We need to give that satellite a name, maybe Elon 1. And now I can create an instance of digital twin, especially for that satellite. So I click on create instance. We see here in the project browser, there are new elements in a new package. Those will represent this specific satellite in the future. So I can make changes and still reference this exact satellite and also use it in my MBSE model later. So let's now switch. We can use this button to switch back to the browser. Okay, I have to select the AAS for that. Yeah, it wants to open it. So open AAS in web view, and then it jumps into the basics web UI, and I can see here there's the Elon 1 satellite, and I can click it, and then I can see what are the things that are created here, and I can see that it created a submodel, and underneath it created entities, so-called AAS entities. It interpreted the parts of the system model as asset administration shell entities. And then we see our temperature sensor, and we see we have manufacturer, it is a string, and we see our temperature, it is as float, and we see our initial values we set. And now we can put our real sensor into play and connect it to the asset administration shell to fill this field with real-time data. And as you can see, if we click here on temperature, we also have the whole description part and everything that I showed you inside the Enterprise Architect. We have that now inside our asset administration shell. So I could go more into detail, but let's switch to our second use case so that I can show you that. I will go back to Enterprise Architect, but this time in a different model. This model is the contact information template. So as I said before, we have different submodels standardized by EDTA. And this is one of the standardized submodels we have available to download. If you download such a standardized submodel, you always get a PDF file with the specification, and you get an AASX file, an offline format for digital for the asset administration shell. So what I did here is I took the PDF contents and modeled it one by one, exactly as it is specified in the PDF file. And this was kind of my evaluation case. So I wanted to evaluate if my result is one-to-one the AASX file that is also provided by the EDTA. And the funny part is, if you compare the PDF to the AES file, you see that there are little differences in the descriptions, for example. And this is the case because first the PDF was structured and the design was made. And inside the PDF, you also see here the UML, as you can see it here. And afterwards, it was rebuilt by hand in AES and ready to use asset administration shell. And the problem, if you do that, you see that already, you don't have a single source of truth. So you maybe your information will diverge. And as you can see here, I modeled that contact information with all the information that is also given by the ETTA. And I again added here on top a submodel and the asset administration shell I need to publish it. So I again can click here, and then I can click here this button, provide as AAS type. This will work as an asset administration shell template. You can use that then to later create instances of contact information for different people, for different companies, for example. So if I click that, it will again create it, generate that inside the asset administration shell. So I will switch back into my, I can use the button again. I will switch back to my browser. And you see now, here's the contact information AAS model. It is the template. So you can click here, you see submodel template. And if you click in it, you can see the decomposition that it's exactly as in the enterprise architect model. You see here, email, for example, for a certain contact. And what's here, the big advantage is that you have a single source of truth. So you can take this enterprise architect model for maybe if you want for future submodels that you want to have standardized, you can design it directly here in MBSE tooling to be sure that you have a single source of truth. So you can generate your documentation from it, and you can also generate the asset administration shell or AASX file from it, basically. Yeah, so this is the big advantage when creating it from scratch in Enterprise Architect. And as you can see, you have here, in contrast to the satellite model, where you just took an existing model, you can here use also the AAS meta model stereotypes inside your UML objects. So this will be exactly mapped as you create it here inside the model. And other hand, in the satellite model, you don't have that. You just use an already existing model, and then it will be interpreted as AAS entities, because entities are some kind of subsystems inside your asset administration shell. So this is a very good place to start, but you could also change them later. Yeah. So this is the idea behind the approach. One more thing to mention is that you are free to use any framework, any modeling framework. So you could use plain UML, but you could also use SysML or other frameworks, as long as it's, for now, as long as it's in Enterprise Architect, it will analyze the system decomposition and generate it inside the asset administration shell. So this is it for my part. I would hand over again to Daniel, that
sure.
will tell you a little bit more about what you can do now for different digital twins based on this MBSE model.
Yeah, sure. Happy to take over. By the way, you accidentally just answered a question by Marcel. So yes, you can use any language you want within the enterprise architect. So it can also be unstructured in the end. But so let me take over from here. What Philippe has been telling you for now, in the context of what we said, we want to bridge these two sides, is how can we get from the enterprise architecture to the asset administration shell, let's say. So why would you want to do that? Philippe showed, well, for existing systems engineering model, the asset administration shell provides us a standardized interface in the end with basics. So you have HTTP REST, you have MQTT endpoints to actually get data there, and connect your models with operational and semantic data. So we've seen the degrees in which temperature is measured, but you also have the whole E-class ecosystem available. And then what Philippe showed us was you have standardized data structure, and on the one point, if you model them in the enterprise architect, you have a single source of truth. But once you did that once, so you did that once, and then you can use them in a drag and drop fashion with these templates to just instantiate new contact information, for example, new instances of these data structures. So two big benefits why it makes sense to go from the enterprise architect to the asset administration shell. What I want to show for now also is why does it make sense to, or how also to use this whole systems engineering power that we have in the enterprise architect for digital twins, to make the point to, in the end, this one here, to say the asset administration shells we want to do this design from scratch. Let's not do that in the asset administration shell tooling, but let's do it in the enterprise architect right away. So what does not work yet is to actually generate enterprise architecture models from the asset administration shell. But if we can start modeling them right away in the enterprise architect in any structure we want, as Philippe said, it doesn't have to be SysML, UML. It just has to be an enterprise architect model for now. And then we can just generate the asset administration shell anyways. And the benefit here is that we can leverage this whole systems engineering power. What does it mean? We are not focused just on digital twins, but we can put this whole drill down architecture that Philippe showed. So this is just a picture that of the model that Philippe showed. You have on top of the information on the data, you also have information, let's say metadata on how do all these components connect to the actual AES space satellite. But of course, in the systems engineering space, you can go much farther. Let's just use the example of we have 3 different satellites. So we don't just have this one satellite that has a mobility block, energy management, environmental observation system, but 3 different kinds of satellites, a communication satellite that uses TV data and forwards it to somewhere else in the world, a sun-synchronous orbit satellite, so that moves in sync with the sun, and a low Earth orbit satellite, so that is used for measuring, let's say, live data in the end of the Earth. And that also means if you want to have, for example, a more object-centric view, we have 9 different satellites. I was not as creative as Philip and called it ELEARN or something. S1 stands for satellite 1, and then we have 1 to 9. 9 satellites that move around in the Earth. If we would model this in an AES tool, I mean, you could do this in an AES tool and somehow also connect it to the types. But well, we easily get this out of the box from the enterprise architect. If we have the satellites also in the enterprise architect, then we know, okay, satellite S4 is a sun-synchronous orbit satellite. And then, of course, you can go further and also connect these satellites with other assets that we have. For example, if we have sensors that emit data, we can model the data centers on Earth where they send this to. So for example, satellite S4 and S6, they send data to a data center in Houston, and then the other satellites, they send data to Vienna. All this information we can represent in the enterprise architect, obviously, which would already be hard to do in the asset administration shell. And of course, we can also add behavioral information. That's something we cannot do in the asset administration shell yet in a standardized way. But for example, in the enterprise architect, we could just say, okay, let me use my mouse here. These 3 satellites are different satellites, but they all have the same behavior when it comes to flying, in the sense of we are modeling a state machine, how they are, well, which states they are in, and what this means for their possible behavior. So all these things modeling the enterprise architect hard or not possible to do in asset administration shell tooling. And we can also use different views. So this would be one, let's say, object. This is, let's say, a structural view, drill down view. This would be a more object-oriented view. We can add behavior here already, but we could also say, let's focus on behavior and have a more manufacturing-oriented view in the sense of, let's zoom into our communication satellite. Well, for example, in context of the digital ESPR, European Sustainable Product Regulation, also satellites and other products, if they are sold within the European Union, regardless of where they come from, they have to provide a digital product passport, so a QR code, that gives access to certain data. And one of these data is, for example, the carbon footprint that was emitted in order to manufacture this product. And what we can do, for example, in BPNN, we could model the manufacturing process, and we could say this manufacturing process, okay, it creates the communication satellite, and it also fills the information on the carbon footprint. Then we could even, by double-clicking, I can't do this in PowerPoint, but in Enterprise Architect, we can just double-click this and have all the information on the actual manufacturing process. Always stay on this higher level, and we say, let's focus on the inputs and outputs. So in order to produce the communication satellite, we need an energy management component, we need an environmental observation component, and we do need a mobility block. So the process uses these things in order to create the communication satellite and calculate the carbon footprint. And for that, it also requires some, so to mount all of these things into the actual satellite, it needs a mounting production cell. And also, this is not just done by human, but in collaboration with a mounting robot. Another view which we can create in this whole systems engineering MBSE world view, let's say, of our system, instead of just focusing on the digital twins. So point is, let's use the systems engineering power for modeling our digital twins. And the last point is, if we do that, we can also use tools in the enterprise architect context, for example, for Git-based configuration management. What does this mean? Git-based configuration management. Well, again, we're now at this point where we're talking on top of the enterprise architect. We're also talking about tools like the LemonTree that are available inside the enterprise architect. And if we model our digital twin in the enterprise architect, of course, we can also use LemonTree. And why would you do that? Configuration management. What does this mean in our example? Let's say we have two different satellites, communication satellites, sun-synchronous orbit satellites. Well, all of them have a carbon footprint that we have to provide via QR code. They have an energy management system, and they have an environmental observation system. So one thing we might want to know is, what's the difference between a communication satellite and a sun-synchronous orbit satellite? And in practice, in the end, one difference can be, well, the communication satellite, it receives and forwards data, TV data in the end via environmental observation. So maybe that's not the best way to phrase it, but it's the same component. So it uses this environmental observation component to receive data, for example, TV data, and forward it to somewhere else in the world where this data could otherwise not be transmitted, so satellite TV. And it also emits data on the remaining battery power. So we said there's an energy management component, and we have the solar cell, but also some battery to make sure that the satellite always moves, and it emits information on, let's say, the remaining battery power. Now, in the sun-synchronous orbit satellite, there is a different use case. It emits temperature and magnetic force data. So data on the temperature and magnetic force. And because it moves in sync with the sun, it doesn't use a battery, or at least it doesn't emit data on the battery power, because it's powered solely by the solar panel. Let's say at least in theory. So from this slide, now you know what's the difference. But the point here is, how do you know this from the MBSE, from the model? And that's actually one thing that's in existing AES tooling. So we examined this, we wrote a white paper on this, and also published this with the Open Industry for Zero Alliance. It's not really possible to show this in a nice way in existing AES tooling. what's the difference between these two models? And also in the enterprise architect, of course, you can now drill down and look, compare these, have two screens and check what's the actual difference. Open the whole model. If you want, you can even go into the XML and try what the difference is. But just from this high-level view, you don't see the actual these bullet points as comparison. But that's where tools like LemonTree from LibreLibre come in, where you can see you have this visual representation of the difference between two models. That's something you can do in the enterprise architect again, but you can't do it in existing AES tooling. And let's briefly switch to LemonTree. What you can see here, this is the LemonTree view, and in this example, we have the two models, the communication satellite and the sun satellite. We have them open, and now we have this whole tree-based view where we already see in different colors where are changes. So for example, we see that the magnetometer, it's available in the sun satellite, but not available in the communication satellites. There are new sensors that were added, and of course the TV, emitter, and receiver. This is relevant for the communication satellites. So these are the things that are changed in the communication satellite, sun satellite. But if you don't want to go through a tree-based view, you also have a visual representation where you can nicely see the difference. Let me fix this a bit. Here we go. So you see this bill of materials, we called it, in the communication satellite. You have the same carbon, you have the carbon footprint, the energy management, you have the environmental observation where you have TV emitter, TV receiver. But in the sun satellite, you actually have the different sensors, the magnetometer and the temperature sensor. So these are green because they're added. And then you also see that because there is no battery in the sun satellite, there is also a lower product carbon footprint. So with one view, you nicely see the differences in the different models, what was added, what was changed. And you also see, okay, these two sensors, they're not here anymore. Yeah, that's one point where you can end. The nice thing about the enterprise architect, of course, this tool you could also use standalone, LemonTree, but if you use the enterprise architect, so let's briefly switch to the enterprise architect. This is the AES-based satellite model that Philippe has shown you earlier. If you have LemonTree available, you can also, if you click on the specialized view, you have all the configuration management you have built into Enterprise Architect. And one very nice thing is you also have how this works, let's say under the hood, is it uses a version management tool called Git. So for all of the coders in the room, well, you know the power of this. First of all, you can use Git. You don't have to use the command line. You can do comparison from this model that you have in here with another model. For example, the model of the communication satellite. You can do that from outside of the enterprise architect. You don't have to leave your modeling environment. And you can also create new versions of the satellite. If you have done changes, you create a new version. You can commit and push it. And that means that all the other people using the same model, they have it available out of the box. And that's not just the case for your digital twin. So if you follow this structure, this is not just the case for a digital twin, but also for all the other MBSE models that you have, and of course for all the code that you have. So on Git, you can store all these things and have a common single source of truth of a specific configuration that you are developing. For example, this communication satellite. So you have in one branch, you have all the models and the code for the specific satellite. And then you can use one tool like LemonTree to compare it to other satellites or to previous versions. So in the end, that's the main points we want to make for today. So how do we bridge systems and digital twin engineering? Well, first of all, We can, why would you do that? We can connect enterprise architect models with operational semantic data, drag and drop of standardized data structures, use the systems engineering power for digital twins, and more specifically, use tools like LemonTree for Git-based configuration management. So we hope we have shown you this whole power of things that are possible. We are aware that this was very, very dense. I think 40 minutes. A lot of input because there are many things that are actually possible. So we don't want to leave it here and also show you what can you do next. For example, why did I not go further into this version management? Because we will provide a dedicated workshop on this. But for now, 2 upcoming events that will be hosted in Austria. So for some of you that might involve a flight. First of all, quite soon actually on 25th and 26th of March, we will have the so-called Asset Administration Shell Summit, the first of its kind, where we will focus for 1.5 days on digital twins and all topics surrounding this interoperable standardized digital twins, data integrity, interoperability, sovereignty with data bases, all these topics and use cases surrounding it will be covered. There are still some spaces left, so in case you're interested and have time, feel free to register. Within the next days, the registration will close soon. There's still more time for you to register for the MBSE Summit. So digital twin side, MBSE side, well, Liebe is hosting for the 6th time, I think now, the MBSE Summit in Traunkirchen. Very nice location, very nice place to join and discuss for also, I think, 1.5 days, all topics relevant to MBSE. There is the lineup for this year is already out, so feel free to check out the website. The slides will be provided. And the main teaser for today that Philip already mentioned in the beginning, if you want to dig deeper into the topics of today, so bridging systems engineering and digital twins with asset administration shell and enterprise architect, we are providing a series of 3 workshops. Why 3 workshops? Of course, the main workshop is the one on April 23rd, where we will dig for a whole 3 or 4 hours. All of them are provided, all of them are online, so you can join from wherever in the world. How to generate asset administration shells from enterprise architect models. We've shown you the power of this today in theory. We'll do this in practice for a whole half day, or Philippe mostly will do this for a whole half day with you hands-on with the plugin. You will get access to the plugin. You will need an enterprise architect. You will get the basics and see how this works in practice. And to prime you a bit, let's say for this main event, we also provide two more workshops in case you want to dig more into the asset administration shell itself. So some foundations of the asset administration shell are expected, of course, on April 23rd. So the day before, we have a whole half day on the asset administration shell. And why would you care about it? Why would you care about digital twins? And also hands-on experience, modeling your first asset administration shells, setting up basics, and understanding in the end, the business value that quick wins with the asset administration shell can bring. And we actually start the series with a workshop by Liebe on version control and variant management. So configuration management for SysML models. If this teaser I made today in the at the end, let's do configuration management with the LemonTree for our digital twins. If this caught you and you want to dig into this before doing the other workshops, feel free to register for the workshop on April 20. Details and registration are available via this QR code or via the link you have here. Again, the slides will be provided. And as Philip already said, there is, if you are one of the lucky people who registered for the workshop today, you stuck with us for 45 minutes now. We value your time in the sense of we also provide you with this discount. If you want to dig into these topics, feel free to use it. It's available if you book all 3 workshops. So for one workshop, I think it's 600 euros. For all 3, it's 1,200 euros. If you use this discount code for all 3, you save 400 euros. But we are also aware that not all of you will be available at this time, or you don't like online workshops, you want to discuss in more private setting. We also provide this as in-house workshop. So all of these topics, let's just discuss and find a tailored solution for you. For that, just contact us via office@twintech.it. But that's it for today from our side. So we're happy to discuss with you now. I will continue sharing, but Philip, please feel free to take over for the discussion.
Thank you, Daniel. Yes, I already answered some of the questions, or one question was already answered by you because it was just asked at the perfect time. So just when Philip mentioned that it's not just limited to UML, so then the question popped up. It is a little bit related to this. So the question is if the plugin for the AES export it's basically related to this plugin. So first question is it only available for Enterprise Architect, or is there possible way to use it with other modeling tools?
At the moment, it is only provided for Enterprise Architect. We were thinking about transporting it to other tools too. The nice thing with Enterprise Architect, it's very good to write plugins for it. So this is why we have chosen Enterprise Architect as a tool. Yeah, so at the moment, only Enterprise Architect, but maybe in the future more tools.
Yeah, but also open to discuss your requirements, I would say. If you have a use case in mind where it makes sense to use another tool, feel free to contact us, I would say.
Okay. So then also related to the plugin, how to get the export plugin and where to get it from?
At the moment, it is still in development. So at the moment, there's no place to buy it or download it. If you register for the workshops you can see on the slides right now, you will definitely get a version of it to try it out. And we're currently in the publishing process. So it will be buyable, downloadable soon. But at the moment, we are in the last phases of development. Yeah.
But I would also emphasize, I think using registering to the workshop is also the intended way to get access to this in the first hand. So be the first users, and yeah, then you don't not just have the know-how, but also the tool available.
Right. Yeah.
Okay. Next one is regarding the changes to the architecture. So what will happen if you change the architecture in the model? Or will this be propagated automatically to the twins, or do you have to do that manually?
As you saw, maybe in the tool, there was also a button for updating. So with this updating button, you will trigger the process of transforming your digital twin to your changes in your model. So this is something this will work too. It won't be automatically because we want to be sure that the modeler is always sure that you have time to make your changes, and then when you're sure you're finished with your changes, you trigger that and it will go online basically.
Maybe I can also add something here using maybe this view. Maybe also one insight in practice. So that's the technical part. I think one thing I learned, or we learned also in practice, one very big issue is, first of all, the synchronization, yes, but also understanding on a high level view how my digital twins look like. Because, well, you have the interface via basics, but if you think about the digital product passport, that means that each, for example, if you use an example of a bike manufacturers have thousands of bikes that they sell each day, and each of them will have a unique identifier, and you need to be able, if someone via the ESPR, someone wants to get a repair of this bike, you need to have the correct bill of materials available for this bike. And what people are struggling with these days is really having this configuration management, knowing what's inside bike number one in contrast to bike number two. And so without the synchronization, having this meta information on what's actually in the model, what's actually in the digital twin is already very, very helpful in my opinion.
Maybe related to this topic, another question was if the plugin is mainly intended for managing different versions of the same system.
I would say we would have to I don't know, maybe the question target is it about versions or variants? So yeah, you can manage different versioning of your system by using Git, for example, in the background of your MBSE model, and then you can generate different versions of your digital twin. But you can also use tools like LemonTree to have different variants of your system and then generate the variants of your system as Daniel showed them as digital twins. So you also have different variants for the satellite, for example, which you can then easily create from the enterprise architect and then generate those variants as digital twins. I don't know, what was that the target of the question? If not, let me know. I can rephrase.
Yeah. I
Okay,
think
then
maybe one
yeah.
thing to add here, I think there are also different approaches here. Just to throw in a few buzzwords, let's say platform engineering or Git flow in the end with feature-based branching. I think these are all techniques you can use, and you can also use them in the context of this plugin.
And maybe additional comment, you can of course have different assets in your model. So your model could be a systems of systems, and you have maybe 5, 4, or 20 asset administration shells you want to generate from that one model. You could also do that.
Just like here.
Yep.
And by the way, since the satellites are Houston and Vienna, I'm not sure if it's on purpose because Lieber's location is in Vienna and our US-based location is in Houston, so that's a nice coincidence. I'm not sure if it was on purpose, but
not just by accident, yeah.
Okay, that's very nice. Another question we have is it possible to simulate what will happen with this digital twin during a number of scenarios?
Yeah, basically you can take the data of your digital twin and you can handle it as simulation. So what I have in mind is maybe you want to simulate a satellite before really building it and shooting it up into space. So maybe you generate a simulation satellite out of this information. And then, of course, you have to fill it with some simulation data. So the data that later will be the real-time data. So this is not scope of the enterprise architect anymore, I think, but I don't know. Maybe you could also use simulation techniques of enterprise architect to do that. But I think you could also use other simulation tools to then put data into your simulation satellite and take data from it. So yeah, this is all possible. Yeah.
I can also add here it's actually possible in the enterprise architect. You can, for example, BPMN models you can simulate, or via the forgot the name, but you can also generate code or simulation code or use.
Yeah, executable state machine, for example.
Yeah, exactly. Yeah, state machines. You can generate executable state machines from that. But what another projects we did with TwinTech and Lieber was there Git comes into place, because you always have to be careful that your digital or the simulation is still in the same version and variant than the actual model and the actual code. But for that, you again have LemonTree and Git.
Okay, there's another one, and I take this over because it's indirectly addressed to me and I can answer it pretty quickly. So the workshop on the 20th of April about version control and variant management, is it about just using LemonTree and other tools, or is it about methodology and best practices? It is about LemonTree, of course, but not just about using the tool. It's about enterprise architect in general. So how to use EA with system models and how to apply version controlling with these models and how this is done in the best way and how variant management can be done using a Git approach. So it's not just about the LemonTree tooling, but also the full workflow of how this is used in combination with enterprise architect, Git, LemonTree, and so on. And then we have one final question. So the AAS is a kind of a view, like a construction view. Could I instead write all the supply info, etc., into a standard UML view, like a component diagram?
Basically, yes. So I think because what I showed first, the satellite model, that wasn't built up for AAS generation. So that you can think about every gray box is already existent as your system model with the decomposition. So as long as you have elements that are decomposed of other elements that have properties, and you can do that uh, on many layers, you are able to generate a digital twin out of it. It will interpret that not stereotype with the AAS stereotypes. Everything will be generated as asset administration shell entities, and those entities are quite good thing to do that, because if you want, you could say this entity has its own asset administration shell. This is also a possibility that you have in the asset administration shell meta model. So basically, yes, you don't have to use the AAS in mind. You could just put that on any system that is already existent and has a decomposition.
Maybe I can also add here, I think this question also targets a bit into the direction of why would you need an asset administration shell? So maybe let me add here, well, in the end, so why would we need the asset administration shell if we already have the class diagram, for example? In the end, it gives you a standardized interface for semantic, so e-class, but also live operational data, because you have the REST and MQTT, etc. endpoints, and also in a scalable way. So there are a lot of commercial tools that build upon this, and it's also standardized. So these are the main points. And the point we made today is, well, let's reuse all the information we already have in the class diagram by, as you said, Philippe, putting the stereotypes there and tagging this information as an administration shell. And the rest
And
is automated.
one more thing, you don't need to have that all on one diagram. So not the diagram is analyzed, but the structure. So basically, every decomposition that is in the background in the model it's saved will be analyzed, not only
Yeah.
what is shown on the diagram. But there's also a button where you can control what should be transferred, but in the end, all the decomposition of an element will be transferred.
Okay, thanks guys for this insights and answering all the questions. We actually made it through the questions, and we're also at the end of the slot. So thank you. Thanks to all the participants
Thank you.
for joining, for all the interesting questions, and yeah, hopefully we will see one or two of you in the workshops in April. Thank you very much. Have a nice remaining day. Bye bye.
Yeah, thank you, everyone.